Starting with two lines A and B, not commensurable in square, where the sum of squares is rational but their product is medial. If we add them together, we'll show we get an irrational number. AB is medial, so 2AB is medial. But a squared plus b squared is rational, so 2ab and a squared plus b squared are incommensurable. Or that a squared plus 2ab plus b squared, equaling a plus b squared, and a squared plus b squared are incommensurable. So a plus b squared is irrational, so a plus b is irrational. We'll call it major. So overall, a major number is the sum of two numbers, a and b, not commensurable in square, whose sum of squares is rational and whose product is medial. An example of a major is the square root of 6 minus root 6 plus the square root of 6 plus root 6. To show this, let a equal the square root of 6 plus root 6 and b equal the square root of 6 minus root 6, which are not commensurable. This wasn't clear to me, so I'll prove it. Consider c plus root d and c minus root d, and by way of contradiction, assume they have a common measurer, e. So ef equaling c plus root d and eg equaling c minus root d, where f and g are whole numbers. Then e is equal to c plus root d divided by f, so that g over f times c plus root d is equal to c minus root d. So g is equal to f times c minus root d over c plus root d, which is equal to f times c minus root d times c minus root d, all over c plus root d times c minus root d, which is all equal to f times c squared minus 2 times c root d plus d all over c squared minus d. So, no matter what whole number f is, g will always be irrational, so c plus root d and c minus root d have no common measurers. Thus, specifically, 6 plus root 6 and 6 minus root 6, a squared plus b squared, are incommensurable, so a and b are incommensurable in square. A squared plus b squared equals 12, a rational. AB is equal to the square root of 6 minus root 6 times the square root of 6 plus root 6, which is equal to the square root of 6 minus root 6 times 6 plus root 6, which is equal to the square root of 36 minus 6, which is equal to the square root of 30. For the square root of 30 to be a medial area, its square root needs to be medial, so we have the 4 root of 30, which is equal to the square root of 6 times the square root of 5, where the square root of 6 and the square root of 5 are rational by Euclid's definition and commensurable in square only, so the 4th root of 30 is the geometric mean of the square root of 6 and 5, making it medial, so the square root of 30 is a medial area. Thus, overall, the square root of 6 plus root 6 and the square root of 6 minus root 6 are incommensurable in square, whose sum of squares is rational and whose product is medial, so their sum is irrational and the square root of 6 plus root 6 plus the square root of 6 minus root 6 is major. When looking for such numbers, a good rule of thumb is numbers of the form the square root of a plus the square root of a minus root a, but be sure to check all the conditions. Notice that the two numbers are a sort of conjugate of each other.